every one of these numbers separated by a period can be represented with ones and zeros, 8 to be exact, okay? And another 8 here. I'm not gonna put the actual combination of ones and zeros. I don't have that memorized. We'll go over that later. Okay, so ones and zeros, and the combinations, when converted to decimal, can range from 0 to 255 for each one of these octets. They're known as octets. Why? They're represented by 8 bits octet, okay? Depending on which ones are 0 and which ones are 1, the number can range from 0 to 255 on each one of these octets. And again, it's the same example I gave you before. 1, 2, 3, 4, 5, 6, 7, 8. This is a combination of those 8 bits all being 0. This is equal to 0. And I can keep going. I'll add a 1 here. This is going to be equal to 1. So let me do a 1 and a 0. That's going to be 2. 1 and a 1 is going to be 3. This is going to be 4. And I can keep going, combining all these ones and zeros until I have all of them 1, 2, 3, 4, 5, 6, 7, 8 with the number 1 on them. And that's the farthest I can go. And that's gonna be 255. Okay. Now how do I convert from these zeros to decimal, from these ones and zeros, from binary to decimal? There's a chart. So you guys should write this chart down if you haven't seen it before. Okay. And this is for each one of the positions for those binary numbers. So starting from the right, the first position is going to be the number 1. Then the second one is going to be 2. Then you just double. 4, 8, 16, 32, 64, 128. All right, so let's do, if you have 0, 0, 0, and let's do 1 here, 0, 1, 0, 0. This is how you find out what this combination of binary numbers, what it equals to in decimal, right? Everywhere that you see a 1, so right now it's under the 16 and the 4, you're gonna add those two numbers together. And so your decimal should be 20. This is how you convert from binary to decimal, okay? So now using this table, you should be able to convert any binary number to decimal if it's in octets, right? 8 bits of information. So again, these numbers for on this table, 1, 2, 4, 8, 16, 32, 64, and 128 represent the value of the bit on that position, right? So for this bit, the value, if everything was 0, just for that bit right there in that position, which should be the 7th position starting from the right, the value is going to be 64. Okay? So from right now, all you need to know is how to convert to binary. And I'm about to show you how to convert from decimal to binary again. And that's all you have to learn today, okay? The other thing I want you to think about is that there's how many combinations you can have on each octet. So always think about that, because it's gonna matter later on when you're trying to visualize how many IP addresses there are. All right, so let's do convert a number. let's do 21. How do we convert 21 to binary? All right, so this is how you do it. All right, and
you would put a 1 under 16, 4, and 1?
yes. But if you don't want to do the math like that, all you have to do is, does 128 fit inside of 21? And can you subtract 128 from 21? The answer should be no, so you put a 0 there. Okay, then you move to the next one. Can you subtract 64 from 21 without it giving you a negative answer? That should be a no. 32 from 21.
No.
16 from 21.
Yes.
So we do a 1 here, then we subtract 16. Okay, what would the answer be?
5.
Right now, can you subtract 8 from 5?
No.
So you put a 0 there. Can you subtract 4 from 5?
Yes.
All right, so you write down 4, you put a 1 under 4, and then you subtract 1. Can you subtract 2 from 1?
No.
0. Can you subtract 1 from 1 without it being a negative number?
Yes.
Yes, so you put a 1 there, and a 1 here, and you end with 0, but now you have your binary number. All right,